Hey you guys, this is IM3 Unit 3 Notes number 3 called Special Right Triangles here, okay? Go ahead and write down your FLT and then we'll go and get started. So press play whenever you're ready. So here, given a right triangle, so again, we're focusing on right triangles, but now specifically with special angles, whatever that is, you're going to be able to find the lengths of missing sides. So it's very similar to what you guys have been dealing with before, okay? But the thing is, it kind of just depends on what information they give you, and depending on what they give you, you might have to approach it a certain way, okay? So let me recap for you guys. In the previous lessons, you guys learned about the Pythagorean Theorem, okay? So what I want you guys to think right now is, what is the Pythagorean Theorem and what is it for, right? So feel free to look back at your notes if you need to kind of get a little refresher, and press play when you're ready. Okay, the Pythagorean Theorem is basically a theorem for right triangles to help you find the third missing side when you're given two of the other sides, okay? So when you're given two sides, you can find the third, okay? That's known as a squared plus b squared equals c squared, right? Okay, so when you're given two sides, you can find the third. Now, what if you don't have all of that information, right? What if you only have one given side, right? What do? So the next step here is something that you may see is they'll provide angles in the triangle. Okay, so this is what we call special right triangles. So to show you where it comes from first, just so you know that, these mathematicians aren't just making stuff up, it actually comes from somewhere. Think of it this way. So if you guys think about a perfect square, okay, so remember, by definition of a square is all sides are the same, right? Okay, so let's just assume that's a terrible square. Let me go ahead and fix that. Let me see if does it auto generate. Oh yeah, it does. Perfect. Okay, so let's assume that each side length is 1. Okay, just 1 unit. So all side lengths are 1 unit long. Okay, so what happens here is if you were to take a knife or scissors, right, and if you were to cut it from one corner to the opposite corner, we call that a diagonal. If I were to slice it right there, okay? If I were to slice it right there and I got rid of one half of it, let's suppose that we only stare at this half right here. Okay? So some things that you need to know. For a square, not only are the 4 sides congruent or equal, but also the 4 angles are. So right here, that's a right angle, meaning the measure is 90 degrees, okay? Actually, all angles are 90 degrees, okay? But what do you guys think happens to the angle, I'll put it in red here, if the diagonal sliced it, right? Press play when you're ready. So there, that diagonal is actually called an angle bisector. Bisector just means that you cut it in half. So that 90 degrees breaks it up into 2 pieces. Half of 90 is just 45 degrees and 45 degrees. So the same thing would happen down here with 45 degrees and 45 degrees. All right? So again, if I'm only looking at the pink highlighted triangle, okay? So if I were to, let's see if I can partially erase. Yes, I can. If I were to just only look at the pink triangle, this is what I would have, okay? So notice how I have 2 given sides. So if I have two given sides, can I use the Pythagorean theorem? Absolutely. When I'm given two given sides, I could always find the third one. So here we go. We're missing our opposite of the 90 is our c. We're missing our c here. So let me go ahead and plug it into our equation right here and make sure that you guys write this down. So 1 squared plus 1 squared is equal to c squared. Okay, 1 squared is just 1. 1 squared again is also 1, and 1 plus 1 will give you 2. Okay, now that I have the square by itself, I can isolate it by performing the inverse operation. So this tells me that c comes out to radical 2. Okay, so I'm going to put a radical 2 here. Now, this is called a special right triangle. This is called a 45, 45, 90 triangle, okay? It's special in that the sides are all proportional. So here's how I want you guys to think about it. Your first 45, 45, 90 triangle, and I'm not drawing this to scale, okay? So if I have a 45, 45, 90 triangle, here's how you guys remember it, okay? So just think of it as all sides are the same, but the hypotenuse has an extra radical 2. So again, all sides are the same, except the hypotenuse has an extra radical 2. Notice how I put a 1 right here, okay? Because the legs were a length of 1. Okay? So, for instance, you know, back in geometry or integrated math 2, you might have learned it by doing proportions, but as of this point, you want to be able to do it by observation. So let me give you a quick example here. Here's example 1. Okay. Find the missing lengths. Okay. So let's say we had this triangle here. And we'll label the angles. It's given that it's 45, 45, okay? And it's a 90 right there. So suppose I only give you one side, all right? Suppose I only tell you that this side is 3. By observation, you should be able to figure out the other two sides, okay? So I'll use a different color here to show you our thought process. Since this is a 45, 45, 90 triangle, I know all sides have to be somewhat the same. So if this side right here is 3, then I know that this has to be 3. And the hypotenuse also has to be 3. But the hypotenuse, remember the hypotenuse is opposite of the 90. The hypotenuse has the extra radical 2. Okay? And that's it. Let's try a couple more. Okay? So, if I told you that this side down here was 14, go ahead and figure out the two missing sides there. Press play whenever you're ready. So if the bottom length is 14, and this is a 45, 45, 90 triangle, it's special, right? Then that means the left leg right here has to be 14 as well. Hypotenuse also has to be 14, but it has an extra radical 2. And that's it. So if you take a look, when you do by observation, there's not a lot of work to be shown. Okay, here's one more. We can call this part C if you'd like. What if I told you that this is 8 radical 2? Okay, go ahead and figure out the two missing sides there and press play when you're ready. Okay, so here we're given the hypotenuse. which is 8 radical 2. Well, I know that the hypotenuse always has a radical 2, but the number in the front is what's going to be represented for the legs. So the two legs here are going to be 8 and 8. Okay? Okay, so let's try a couple more. It does get a little tricky, but nothing that you guys can't handle. I'm going to go ahead and draw the triangle like this. Okay. Let me go ahead and say that this side is 7. Okay, so a few things here that were intentional. Notice how they didn't give you the third angle, okay? If you know that one angle is 45 and the other one is 90, according to, the sum of the angles in a triangle, that last one has to add up to 180, right? So even if they don't give it to you, you should know that this missing angle here is 45 degrees, okay? Okay, and you guys should know that even though I rotated this triangle, the hypotenuse is always opposite of the 90, okay? So keep that in mind. So they gave us a leg here, so that means that this other leg should be the same. The hypotenuse should be the same, but the hypotenuse has an extra radical 2. Okay, pretty easy to see. So let's do one more. Let's do okay, let's do that one. Press play whenever you're ready or if you're stuck, okay? Okay, so notice how they only give you 2 angles, so you could find the third, which is 45 in this case, because it has to add up to 180 degrees, right? So you're given a leg. You know that the hypotenuse is across from the 90. So no matter how I rotate this triangle, you guys should know, okay? So if the leg is 4/3, then the other leg is also 4/3. So then the hypotenuse should also be 4/3, but with an extra radical 2. And that's it. Okay, and if you're saying to yourself that this is easy because you're just looking at it, it really is that easy. Okay, now I'm going to show you one problem where it requires a little bit of thought. Okay, so I'll draw this one a little bit larger. We can call this part whatever this is. I lost my count. A, B, C, D, E, F. Okay, part F. Okay, now there's this one common scenario where you might get something like this. Okay, so the side that they gave you is the hypotenuse, and we know that because it's opposite of the 90, right? And this is a little bit weird. Can you guys tell how it's a little bit weird, right? Okay, pause if you need to, but think about how this is what makes this a little bit challenging, okay? So if you guys take a look for a 45, 45, 90 triangle, usually opposite of the right angle, the hypotenuse, I'll highlight it here so you guys can see it. All of the hypotenuse has what, right? Take a look at all the hypotenuse. What do they all have in common, those yellow highlights? Okay? They all have a radical 2, which makes it easy, right? Because you just look at the number in the front. But if you notice here, there's no radical 2. So here's a trick that always works. What you do is, if you normally see a radical 2 there, and it's not there, what you do is you put one there. Okay? But isn't that cheating? Right? So here's what you do. You put in another radical 2 at the bottom. Because radical 2 divided by radical 2, you guys know that the same thing divided by itself is always 1, right? But take a look before you write it. I'm going to see if I can kind of squeeze that in there. What you're going to do is you're going to take that denominator, but instead you're going to put it underneath that number. Okay? So take a look. Here's your radical 2. Now, what's in front of the radical 2, right? It's a 15 over radical 2. So over here is going to be a 15 over radical 2. And over here is going to be a 15 over radical 2. Okay? And that generally is your answer right there. Now, there is another step to that. And this is just a matter of preference, okay? I want to show you guys real quick how to, what we call, rationalize the denominator. So it's not illegal if you have a radical in the denominator, but most mathematicians prefer that you don't. Okay? So what you guys do, I'll show you how it works mathematically, and then I'll show you the shortcut, okay? So, sidebar. Let's say you guys had 5 over the square root of 3. The way to rationalize that mathematically is what you do is you multiply top and bottom by the same radical. So the radical that we have here is the square root of 3. So I'm going to multiply top and bottom by the square root of 3. What happens there is you end up getting 5 radical 3 at the top. And radical 3 times radical 3 is just the square root of 9. And the square root of 9 is just 3. Okay? That's how you do it mathematically. I'm going to show you guys a way to take care of it so that it's faster. So here we go. If you have something like 4 over radical 7, okay, here's what you do to jump straight to the answer. You bring your radical to the top. So you put a radical 7 at the top, and you put your radicand at the bottom. So everything inside the square root goes at the bottom. And that's how you get to your answer very quickly. So let's do another one here. I'll do as many as you need to. 5 over radical 6, okay, without doing the mathematical work, that's the same thing as you're putting the radical at the top and the radicand, everything inside the square root, at the bottom. Isn't that a lot faster? Right? So these two, although written very differently, are the same, okay? So take a look here. Let's try this one. Think about what 15 over radical 2 should look like. Press play when you're ready, okay? 15 over radical 2 is the same thing as 15. You put the radical at the top, the radicand at the bottom. So you guys would be writing 15 radical 2 over 2. And you want to pay attention to that when you do your work on delta math, okay? Delta math wants you to rationalize it. Okay? So since this down here is also 15 over radical 2, that's just the same thing as 15 radical 2 over 2. All right? Okay, just one more just to make sure. 8 over the square root of 4. 8 over radical 4. Go ahead and rationalize that and then press play. Okay, that's just going to be 8 radical 4 over 4. Okay, good. Now notice the 8 and the 4 on the outside here could actually divide. So that ends up being 2 radical 4. Sometimes you can reduce it, sometimes you can't. Okay, no big deal. Okay, so two things that you guys just picked up there. Knowing how to rationalize the denominator, but also how to handle it when you don't have a radical 2 in your hypotenuse. Okay, so let's try a couple. Here's part, I think, G. Okay, let's say that this right here was 9. Okay, press play whenever you're ready. Try it out. If you get stuck, that's totally fine. Okay, so I know that opposite of 90 is the hypotenuse. And the hypotenuse for a 45, 45, 90 triangle should have a radical 2, but it's not there. So what you do is you put one in there, but then you balance it by putting one below the 9. Okay? So this is in front of the radical 2. So your two legs are going to be 9 over radical 2, 9 over radical 2. Also known as 9 radical 2 over 2, and 9 radical 2 over 2. Okay? Hopefully you got that. If you didn't, let me know. Let's do one more just to make sure. Okay? Here's another one. And you might have to rotate your paper if you're having trouble drawing right triangles. Let's say that this was 13.264. Okay, go ahead and figure out what the other two legs should be. Press play when you're ready. Okay, so I noticed right away the hypotenuse doesn't have a radical 2, so I'm going to put one in there, but I'm going to balance it by putting one below the number. The value in front of the radical 2 is going to be the same values for my legs. So this is going to be 13.264 radical 2 over 2. And this is also going to be 13.264 radical 2 over 2. Okay? That's the only time it gets a little bit weird. But other than that, by observation or by inspection, it's really easy. Okay? Hopefully you agree. Okay, so that's the cool thing about 45, 45, 90 triangles. They always behave in that same way. So the second type is called a 30, 60, 90 triangle. Okay, so the way to kind of prove that to you guys real quick without having to spend too much time is take a look at this part here. Let's say we had an equilateral triangle, okay? Meaning all sides and all angles are congruent, okay? So, for instance, if I know that this side is 2, then that means this side is 2 and this side is 2, okay? And I know that all angles are 60 degrees because they're all the same and it has to add up to 180, okay? So here's what I want you guys to think about here. If I took a knife or scissors and I were to slice it right in the middle here, shing, how much would this angle be right there and right here? Okay, think about what your answer is there. Press play when you're ready. If you slice that, you actually bisect that angle, so meaning that this angle here is 30 degrees and this angle here is 30 degrees. But also, you bisect that line segment at the bottom, so from here to here, this is 1, and from here to here, this is 1, okay? So take a look. If I focus on just one of the triangles, let's focus on this one, okay? I'm going to go ahead and draw that over here so that you guys don't get confused. Actually, you know what? I can erase. That makes it easier. If I focus on just one of the triangles, okay? Okay. So if I focus on just one of the triangles, this is what I have. Notice how I have 2 given sides, okay? So if you have 2 given sides, can you find the third one? Absolutely. According to the Pythagorean Theorem, if you're given 2 sides, you can always find the third one here. Now, it's not drawn, but right there is your right angle. So go ahead and figure out what a squared plus b squared equals c squared is, okay? Okay, so here you know you're given the hypotenuse because it's opposite of the 90 here. So that's your c. And you're missing either your a or your b. It doesn't matter which one's which. So a squared plus 1 squared equals 2 squared, okay? Now, if I were to solve for this real quick, I would get a squared plus 1 equals 4. And before I can square root, I'm going to have to move over that 1 by subtracting 1. So a squared is equal to 3. And now that I've isolated the square, I can square root both sides. And a comes out to the square root of 3. Okay? So the square root of 3 is on this side. So here's your 30, 60, 90 triangle. No matter how large or small your 30, 60, 90 triangle is, there is a relationship. So what I want you to draw here is this. Okay? And the reason why this is a little bit tricky is because you now actually have to focus on the angles. Because in the 45, 45, 90, both of those angles were the same, so we didn't have to really focus on it. But here, the angles are important. Okay? Here's how you guys remember it. So the rule is the bigger the angle, the bigger the side, right? So if you notice, opposite of 30 degrees is this length right here, right? In orange. And opposite of 60 is that opposite side right there. So notice how when the angle is larger, the opposite side is larger, right? So just keep that in mind for a second. So what we're going to do is we're going to call this the short leg. We're going to call this the long leg. And as always, opposite of the right angle, we call that the hypotenuse. Okay? So here's the relationship, you guys. Let me make some space here. The short leg and the long leg will always be the same. So I'm going to put 1 and 1. Okay? But here's where you guys got to pay attention. Opposite of the 60 has the extra radical 3. Okay? What we see from here, I'll put it in pink, the hypotenuse is always double the short leg. So if this is 1 down here, the hypotenuse has to be 2. Okay? So once again, short leg and long leg are the same, so 1 and 1, except the long leg, opposite of 60, has an extra radical 3. Okay? And it looks weird at first if this is your first time seeing it, but let's do a couple here. Here's example 2. Same instruction, so I won't write it again. But let's say we had... Let me draw that again. Let's say we had 60 and 30 right there. And let's say I told you guys that this is 4. Okay? So in a 30, 60, 90 triangle, the short leg and the long leg will always be the same. So the long leg will also be 4, but across from 60, you have an extra radical 3. Okay? The hypotenuse is always going to be double the short leg. The short leg is 4, so the hypotenuse will be 8 because you double it. All right? And that's it. Okay, let's do a couple more. All it takes is a little bit of exposure, you guys. Notice how the angles are a little bit different, okay, in terms of its placement. So pay attention to that. Okay, so if I told you that this is 5, okay, what I want you to think about here is what side was given? Was it the short leg, long leg, or the hypotenuse? So since 30 is right here, opposite of 30 is your short leg. Okay? So what do you know about the other two? Press play when you're ready, all right? Okay, so I know that the long leg should be the same. So I'm going to put 5 as well. But 60 has an extra radical 3. Okay? Opposite of 60 always has the extra radical 3. Now, the hypotenuse is always double the short leg. So if the short leg is 5, then the hypotenuse is 10. And that's it. Okay? Here's a couple more. Let's do 30 here and then 60 here. Pay attention to the angles, okay? What if I gave you 18 there? Think about what the other two sides are and then press play whenever you're ready. Okay, so here they gave us the hypotenuse, which is 18. I know that the short leg is opposite of 30. So if the hypotenuse is 18, remember the hypotenuse is double the short leg. So the short leg has to be half of it. So half of 18 is 9. Sometimes people mix up double and half. Just remember that your final answer, the hypotenuse, always has to be the longer one. So it wouldn't make sense to call this, 36 because double 18. So make sure that it makes sense to you guys. Half of 18 is 9. 60 is the longer leg, so that should be 9 as well, but with an extra radical 3. Okay, so hopefully you're seeing the patterns here. We'll do a couple more. Let's draw another one. Here's part D. Let's draw it like this. Okay, let's do 30 and then 60 here. You guys have to pay attention to where the angles are, okay? Because it's not always going to be drawn to scale, so you can't just rely on what looks longer, okay? Let's say I told you that this was 5, okay? Press play when you think you have it, okay? Give it a guess if you're not sure. Okay, here they gave us the hypotenuse. So I know the short leg has to be half of it. It wouldn't make sense to put 10 here because the hypotenuse has to be longer, okay? So people freak out. They're like, wait, 5? I can't cut that in half evenly. So what you do, half of 5 is 2.5, but even easier, you just take 5 and you divide it by 2. You could leave it as a fraction, okay? Actually, it's preferred. So if the hypotenuse is 5, the short leg is half of 5, okay? And if you know the short leg is 5 over 2, what's the long leg, right? It's just the same thing, but with an extra radical 3. And that's it, okay? So notice how opposite of 60 always gives you a radical 3, right? Opposite of 60 gives you a radical 3. Opposite of 60 gives you a radical 3. So let's do one more before we get to the challenging one. Let's say I give you 60 degrees here intentionally. And let's say I told you that this is... okay, so notice how here I didn't give you that third angle, okay? So if you know that this is a 90, this is a 60, so the other one has to be a 30 because it has to add up to 180, okay? So sometimes you do have to fill it in yourself, okay? Now, they give you the long leg here, which is 12 radical 3, okay? So you know opposite of 60 has a radical 3, so the short leg also has to be just the 12, but without the radical 3, okay? And if you know the short leg, the hypotenuse has to be double that. It wouldn't make sense to put 6 there, okay? So make sure that it makes logical sense. Okay, so we did a few. Now, what happens when it doesn't fit so perfectly, right? And this is the example that I want you guys to see. The last one for the day. You guys normally see a radical 3 in front of your 60, right? Or opposite of your 60. So what do you do if it's not there? For instance, what if I told you that this was 10? Okay? Similar to, let me scroll back here. Similar to the 45, 45, 90 triangle, when the hypotenuse doesn't have a radical 2, you put 1 there, right? So we're going to do that same idea here. Normally, there's a radical 3, so there's a radical 3 across the 60. So if it's not there, you're going to physically place one there, but you also got to divide it by the same thing to keep it balanced. But what you do is you kind of take that and you scoot it over under the value, okay? So everything in front of the radical 3, which is the yellow highlight, is going to also be your short leg, 10 over radical 3. Let me scoot that over a little bit. 10 over radical 3. But notice how there's a radical in the denominator, so we have to quickly rationalize it. Press play when you're ready. That's just going to be 10, radical at the top, radicand at the bottom. Okay? Okay. So remember, you have the short leg. So what's the long leg? Sorry, what's the hypotenuse, right? The hypotenuse is always double the short leg. So if this right here is the short leg, the hypotenuse is just going to be 2 times that. Okay? And that comes out to just 20 radical 3 over 3. All right? Let's do a couple more. I want to make sure that you guys are used to this. Let's do 60, 30, and let's do 5. Okay, try this one out here. Find the 2 missing sides. Press play when you're ready. Okay, so normally opposite of 60 should have a radical 3, but it doesn't. So I'll put one there, but I'll have to put one below the value. What's in front of the radical 3 is going to be my short leg as well. So that's going to be 5 over radical 3, also known as 5 radical 3 over 3. I know that my hypotenuse will be double my short leg, so that's just going to be, 2 times that. So that's just going to be 10 radical 3 over 3. Okay? Let's do one more. Last one for the day, okay? Let's say I were to draw it like this. Let's do 60 here, 30 here. So no matter how I rotate it, you guys, pay attention to the angles and what's opposite of those angles, okay? So let's say I told you that this was 100. Okay, go ahead and answer this to the best of your ability. Press play when you're ready. Okay, so they gave me opposite of 60. Now, opposite of 60 should always have a radical 3, so I'll put one there because it's not one. But then I have to balance it by putting it below. What's in front of the radical 3 is going to be my short leg as well. So that's going to be 100 over radical 3, or 100 radical 3 over 3. I know that the hypotenuse will be double that. Why doesn't that work? Will be double that, meaning times 2. So the hypotenuse will be 200 radical 3 over 3. Okay? That's a couple of problems for you guys. We did a few, about maybe 8 of each, okay? But you have more practice on Delta Math. So if you get stuck, just let me know. I'll be happy to help you, okay?